problems based on geometric mean. So here we are going to discuss, or we are going to perform few problems that are based upon the geometric mean, that is denoted by means of GM in an advanced level. Then now the first problem, which is based upon this geometric mean. So here when A, B, C are the three terms which are in geometric progression, then the geometric mean will be given by means of, that is B equals to under root the product of the first and the last terms, that is A and as well as C, that is B equals to root of AC. Then now, so here the problem based upon this GM, that is geometric mean, is of if G1, G2, G3 are three geometric means. So here GM stands for here geometric mean, are the three geometric means between small m and small n. These are the two terms, between these two terms, these are the three geometric means which are inserted. Then, so this is the if condition, which is the given condition up to this extent. So here these are the three geometric means which are to be inserted between these two terms, that is m and as well as n. Then to be proved condition is of, then show that, so you have to prove that G1, G3 is equals to G2 square, then that is equals to Mn, that is the product of m and as well as n. So this is to be proved, and whereas this is the given condition. Then now, since it is show that, so here we have to write it as the proof. We are going to prove the condition, that is G1, G3 equals to G2 square equals to Mn. So in our proof, these are the three geometric means between m and as well as n. So here as per problem, G1, G2, G3 are three GMs, that is geometric means between m and as well as n. Then we have, then we can write, so here then we have, so here as per the problem, m and n are the two terms, m and n are the two terms, and between these two terms there are three geometric means, that is G1, G2, G3 to be inserted. So here I am going to what I say, write G1, G2, G3, then comma n, then now here comma m. So here three geometric means are between two terms, that is m and n. On the whole there are of 5 terms. So here 3 plus 2, that is of 5 terms. Then now the first term will be of m, the last term, that is the fifth term, will be of n. Second term is G1, third term is G2, fourth term is G3, and the fifth term will be of n. So that implies m, G1, G2, G3, n. Since these three, that is G1, G2, G3 are the geometric means between m and n, then automatically m, G1, G2, G3, n are said to be in the progression, that is geometric progression. So here let us assume the T1, the first term as m, the second term as G1, the third term as G2, third term as, so fourth term as G3, and the fifth term as n. But when the 5 terms are in GP, the condition for GP will be off. So here let us write the condition of geometric progression. then what will be the condition of the geometric progression? When three terms are in, that is A, B, C are in geometric progression, the second term divided by the ratio by the first term, that is B divided by A, will be equals to third term divided by the second term. But whereas here the condition for of GP will be of, so here when these five terms are in GP, the condition will be of the ratio of the first two terms will be equal to the ratio of the second and third terms, and the ratio of the will be equal to the ratio of the third and fourth terms, and will be equal to the ratio of fourth and the fifth terms. So we can write it as, the ratio can also be written as the ratio of the first two, that can be written as T2 by T1 is equals to the ratio between the next two terms, that is T2 and as well as T3, can be written as T3 divided by T2 will be equal to the ratio between the third and fourth terms. So here fourth term overall divided by third term is equals to ratio between 4 and 5 terms, that is fifth term divided by fourth term. So here these symbols are of equal to, so here the ratios are equal, the ratio is equal throughout the sequence of this GP. So hence it is the common ratio. Then now that implies, but T2 as per this sequence of the GP, second term T2 is of G1. Let's write G1 numerator divided by T1. The first term is of M is equals to third term. The third term in the sequence is of G2. Let's write G2 divided by T2. Second term is of G1, so let us write G1 in the denominator. That equals to T4 is of G3 divided by T3, that is third term is of G2 in the sequence. That equals to last ratio, that is the T5 by T4. T5, the fifth term, is denoted by means of N divided by T4, the fourth term by means of G3. Then now, so here since all these ratios, four ratios are equal, so here we can equate any two and any two, so in the two forms. So here I want to equate the first and the last, that is the mean extremes, and the second and the third, which is means. So now, so here I can make two forms here, that is G1 by M will be equals to N by G3. So G1 divided by M is equals to N by G3 as the first condition which I have framed from these four equal ratios, and the next condition which I am going to frame is about the means which are in between. So G2 by G1 is equals to G3 divided by G2, whereas in the next logical step I am going to what I say cross multiply, whereas here also in the second condition, so I am going to cross multiply. So here I want to cross multiply by cross multiplying in both the conditions. So here in both the conditions I am going to cross multiply. Then now the first condition, G1 by M is equals to N by G3. G1 by M is equals to N by G3. So here I have cross multiplied, this is the first case. So this is case number 1. In case number 1, when we cross multiply, then G1 into G3, so here that implies G1 dot G3 is equals to M into N, that is, so that implies G1 G3 is equals to Mn. So let us write this as the equation number 1 from the first case. Then now similarly in the case number 2, the case number 2 is of G2 by G1 is equals to G3 by G2. So here G2 by G1 is equals to G3, the third by G2. So here I have to cross multiply. By cross multiplying, the next logical step will be of, so that implies G2 into G2. So let us write as G2 into G2 itself, then that is equals to G1 into G3. G1 dot G3. So here that implies, so here G2 raised to the power of 1 and G2 raised to the power of 1. So here bases are same. So into between the product rule applies here. So here exponents must be added up, 1 plus 1 will be 2, or G2 into G2 equals to G2 square, just as x into x will be of x square. So that is equals to G1 into G3. So in this manner I got. So here this as the second equation. So now let us observe first and second equations. So here from 1 and 2 equations, so from 1 and 2 equations, the first equation is of G1 G3 is equals to G1 G3 equals to Mn. It is of the first equation, and as well as, so here G2 square equals to G1 G3. So here G2 square is equals to G1 G3. So here let us write this as the second equation. So from 1 and 2 equations, so I am going to write it as the second one. So I want to write the second one as, so here G2 square, that is G2 square equals to G1 G3. So here second equation I wrote as it is, that is G2 square equals to G1 G3. But this G1 G3, but this G1 G3 is again equal to Mn. So instead of this G1 G3, I can replace it by means of Mn. So here hence, so here therefore all these three terms are equal. So we can write in any order. So I want to write as here G1 G3 is equals to G2 square is equals to Mn. So this is the condition which is to be proved as per the problem. So here we have to prove G1 G3 equals to G2 square equals to Mn. So in this manner I say here we proved that G1 G3 equals to G2 square equals to Mn. So here hence it is proved.